Welcome everyone today. I just wanted to say thank you for taking the time to join us for this session today. My name is Kayla Burkholder and I will be the host for the webinar today. We have a really great session planned for you today, but for those of you that aren't familiar with Brinqa, we are a software product company with a focus on enterprise cyber risk management. Today we're going to be talking about vulnerability risk management. In this case, some of the largest retailers in the world, medical insurance firms, and U.S. electric utility providers are just some of the industry leaders that rely on Brinqa and the vulnerability risk management platform that we use to secure their critical assets. So how do these cybersecurity organizations representing some of the most complex, diverse, and vast technological ecosystems in the world tackle this most pressing vulnerability management problems today? So today we'll be covering a couple different lessons from the trenches. How do top risk leaders and organizations approach risk prioritization? How do we reduce remediation overhead while improving effectiveness? How can you gain insights into emerging threats like Meltdown and Spectre? And then how do you future-proof your vulnerability risk management program? At the end, we will have a Q&A section. So feel free to send us your questions through the webinar client, and we'll try to get to as many of those at the end as possible. If we don't, you are always free to shoot us an email too. Your speakers today are Syed Abdur and James Walta. Syed is our Director of Product Management. He is responsible for driving the overall strategy and technical direction of Brinqa product lines. His previous experiences include technical software development and delivering large enterprise security applications at Sun Microsystems and Oracle. We also have James Walta on the line. He's our sales engineer. He's currently the lead sales engineer at Brinqa for the US and Europe. Prior to joining Brinqa, he worked as the sales engineer at National Instruments, where he focused on solutions for software and hardware automation. I'm going to go ahead and hand it over to Syed to go over the agenda for today, and then we'll kick it off.
Awesome. Thank you so much, Kayla. And welcome everybody that's on live. We really appreciate you taking some time out of your busy schedules to be on this webinar with us. So like Kayla said, for this webinar, we really want to focus on things that we see in the field when we talk to our customers and our prospects in terms of what are the main challenges that they're seeing in the vulnerability risk management space. So in this webinar, we'll do a quick brief introduction about Brinqa, who we are, what we provide. Then we're going to take a deep dive into vulnerability risk management as a problem space. We're going to look at a common process that most folks have for managing vulnerability risk, and then also look at some general challenges that most organizations face. And then we're going to look at knowledge graphs, which is really a very central idea to the way that we approach this problem, and we're going to see how that can address some of the challenges that we see in the space. We're going to do a quick overview of the Brinqa Cyber Risk Services, and then we're really going to get into what you're here for, which is talking about actual lessons from the trenches, actual issues and challenges and concerns that we see when we talk to our customers and prospects. And the first one that we're going to look at is how do you ensure that the risk prioritization processes you have in place are actually addressing the problems that you need to be the most concerned about. Then we're going to look at how you can improve remediation effectiveness and coverage, and also reduce remediation overhead at the same time. We're going to look at how a few different approaches for how you can respond to emerging threats like 0 days or something like Spectre or Meltdown, special cases of vulnerability management where you do need to have some additional processes in place. And then we're going to talk about how you can future-proof this whole process and what that really means to make sure that you're not only doing things to be efficient and effective today, but you're also planning for the future and making sure that your program really stands the test of time. And then we're also going to look at some alternative approaches to vulnerability monitoring that you can use to augment your more traditional scanning-based approaches. And then finally, like Kayla said, we will have a Q&A session at the end. So if you have any questions, please send them through the BrightTalk interface. Okay, So really quickly, so Brinqa is a cyber risk management firm. We're based out of Austin, Texas. And our emphasis is really on helping our customers implement a knowledge-driven approach to managing cyber risk. So making sure that all of the data that is necessary for analyzing a specific risk situation or circumstance, we want to make sure that all of that information is built into your processes and it's available really easily and very accessibly so that you can take these decisions in runtime or upfront when you're doing planning, but making sure that you have this full visibility into your data infrastructure. And our customers tend to vary quite significantly in terms of their industries and their size. Some of the bigger industry segments that are represented by our customers are critical infrastructure, things like your gas and electric utilities providers, your airlines, your oil and natural gas companies, fairly big on the financial services sector as well, so your investment banks, your back-end processing data centers, and things like healthcare, insurance. These tend to be the bigger segments for us, but we also see quite a variation in the size of the companies that we typically work with. So the smaller end of the spectrum would probably be a few thousand assets to maybe 10 or tens of thousands of assets. The medium range is more represented by customers who have hundreds of thousands of assets. And on the larger end of the spectrum, we have actually had customers that have more than 1 million assets. So really when we're talking about the diversity or the range of folks that we work with, we see a lot of really interesting use cases, and that's really what we wanted to share with you on this webinar, especially for the enterprises that are either really large in scale or that have really non-traditional infrastructures. It really pushes the boundary for us in terms of how we want to think about vulnerability risk management and how we want to approach it. But just in general, most of our customers are using the Brinqa Risk Platform to understand and measure security risk. So based on, again, any monitoring and assessment systems that they might have, any asset management systems that they have, any kind of security intelligence systems that they have. How do you essentially bring all of that together to get a real accurate perspective on risk? And then once we understand what the risks are, we are able to prioritize them and eliminate those risks by putting in processes for remediation and mitigation. And then throughout this process, we want to make sure that there is really good visibility into the process, so very much focused on providing good metrics, reports, and dashboards to all of your different stakeholders so they can stay engaged and they can be part of the process and they have visibility into what we're doing. And then also really important that we're able to provide real-time answers to risk questions because that's, again, something that a lot of organizations struggle with just because they have so much data and it lives in so many different places. There is generally a significant lag time between when that data is generated and when you're actually able to analyze and take actions on it. So again, that's a point of emphasis for us to make sure that the data in our platform is as close to real time as possible. So let's get into vulnerability risk management. So vulnerability risk management is one of the most prominent applications of the Brinqa Risk Platform. So the Brinqa Risk Platform is really a more general cyber risk analytics and management platform, and it can be applied to a lot of use cases, but vulnerability risk management is the one where we're seeing a lot of traction and we're seeing people get a lot of good results when they apply the risk platform to this process. And the common process for most companies and for most organizations kind of looks like this, where you're bringing in data from your asset management systems, from your vulnerability scanners, from your discovery tools to create essentially these centralized repositories of assets and vulnerabilities. But you're also going and getting additional information about these assets and vulnerabilities, either from your CMDB systems or from any other internal business context type of systems. And then for vulnerabilities, going out to external threat intelligence feeds and getting information about these vulnerabilities and how they're being used and how they're being exploited and so on. But with the goal of bringing all of this information together so we can analyze it, so we can evaluate risk, and so we can prioritize what needs to be fixed after we put all of this context in place. And then once you have prioritized your risks, the goal obviously is to remediate as many of these problems as possible, to get our risk posture as solid as possible. So obviously remediation is again an important aspect of this, where you're actually going and fixing these problems. There are a lot of different ways in which people sort of manage the remediation process. You might have existing ITSM systems and processes that you might want to use for this. So again, a point of emphasis for us is to fit in as seamlessly as possible into any existing remediation processes or ITSM management processes. But the big thing with remediation is that you want to make sure that it's addressing the problems that you have highlighted as major concerns for you, but also that it's effective. So you want to make sure that you're not inundating and spamming your network security professionals or your application developers. You want to make sure that you're giving them as much structure as possible around remediation, so it makes their jobs easier. And then obviously you want to make sure that you're reporting metrics, you're reporting analytics throughout this process to all of your different stakeholders. Now, some common challenges that most organizations face, and it's just really the nature of the problem, are the ones that are listed on this slide. So data overload obviously is a big concern. The bigger the size of the organization, the more severe this problem is, because what we're really talking about is we're talking about anywhere between hundreds of thousands of new vulnerabilities to millions of new vulnerabilities being reported every week, every month, however frequently you're scanning. So then the problem really becomes that if you're getting so much data, how do you really do a good job of identifying what the main problems from this data set are and where you should focus your efforts into fixing problems? And this problem is kind of exacerbated by the fact that the environments that we're scanning, that most organizations are scanning, they're not very homogeneous. So they're pretty diverse in themselves. Most companies are using different scanning tools and different discovery tools. So how do we deal with this process of a lot of data coming in from a lot of different sources? And that's definitely something that a lot of organizations struggle with, especially if you're using manual processes and you're using things like spreadsheets to do your analysis. This can become an absolute nightmare. And then on the other side of things, the attack surface and the attack landscape is also constantly changing. So internally on your side, you have new technologies that are being added into your infrastructure. We have infrastructure as a service now. We have containers. We have OT devices. We have IoT devices. How do you make sure that all of these changes that you're going through to make sure that your organization, stays on the cutting edge of digital transformation, that you're making use of all of these resources? How do you make sure that these are also secured in the right manner? And then externally, similarly, things are always changing. You have new vulnerabilities that are being reported. You have 0 days that are coming in. You have new malwares, new toolkits, new threat actors that are constantly trying to evolve and change just so they can get through the existing security measures that you have in place. So it is a fairly complicated problem. And then once we get into the weeds of the analysis, again, it becomes more complicated because necessarily, since we're talking about a lot of information that is coming from a lot of places, businesses traditionally struggle with building all of that information in one place. So how do you establish the right business context for an asset that you're evaluating? Or if you're looking at a vulnerability and you're trying to decide, whether you should fix it or not, how can you really do that unless you understand how this impacts you? Similarly, the lack of intelligent prioritization mechanisms, looking at, how can we do a better job of remediating things? How can we fix more problems? How can we fix the more severe problems? There needs to be a lot of guidance that has to be provided, because in a lot of cases, folks are doing this manually, and you're taking these decisions on a day-to-day basis, which really hampers how consistent you can be with your efforts. And further, just kind of addressing that, the manual processes that you have in place, they really translate into bad remediation results for you. So one of the surveys that was done by a research organization surveyed about several hundred organizations, and they came back with the results saying that you have between a vulnerability being discovered and it actually being targeted for remediation, you have several hundred days that are spent for that to happen. So again, it needs to be a point of emphasis to streamline this whole process as much as possible. So I promised you that we're going to talk about knowledge graphs. So I think we all understand that the problem of vulnerability management is a fairly complicated problem, and it's complicated because we are talking about the fact that we need to analyze data from a lot of different places, and it's really a challenge to keep all of that information in one place or to have a single pane of glass where you can look at all of that information to take decisions. And knowledge graphs are definitely one solution to the problem. So for those of you that might not be familiar with knowledge graphs, although I can promise everybody has hands-on experience with one, a knowledge graph is a system that acquires and integrates information onto an ontology and applies reasoning to derive new knowledge. Now, all that means is that it's a framework that lets you bring in data from a lot of different places by putting in a foundation for how that data should be processed. And once that data is brought into your framework, all of that data is connected, and you also have mechanisms that are built into the knowledge graph that are automatically going to come up with insights and new knowledge based on the data that you've just put in. Now, this term was really made famous by Google, and it is central to the way that Google search works. So for instance, when you search for a term or anything in Google, you see the display, you see those little index cards on the right. And the index cards are really all the entities and all the results that are mapped to the particular node that you just searched for. So based on all the information that Google has acquired over the years and analysis of how people interact with data and what they're really looking for, they have actually been able to build a good understanding of how different pieces of data are connected together. And that's really what you see on the right. The other big social networks like Facebook and LinkedIn, they also employ the same mechanism. But really what all of these systems are doing is that they're putting an emphasis on the relationship between information. And if you think about it with the vulnerability risk management problem, that is a really, really core problem as well. Like, how do you establish the relationships between this asset and everything that it impacts within my organization? How do you establish the relationships between a particular vulnerability and how it's being used throughout the world? These questions are really, really important because they have a very direct impact on how we prioritize risk. So just sort of digging into the knowledge graph a little bit deeper, what are the core capabilities that a knowledge graph delivers to you? So the first thing is that it's actually a graph. So it's literally a graph behind the covers. It has to be, the data model for a knowledge graph has to be a graph because that is really the only way in which you can connect everything. So with graphs, it doesn't really matter where you start looking at that data. You are actually connected to everything that specific piece of data is connected to. So you can actually take that analysis and put it in a real perspective to get all the information that you need. What does this mean in context of vulnerability management? It means that the knowledge graph would connect all the entities that you need to monitor, as well as all the incidents and problems that you're monitoring, and any associated context with it. So in our case, it would link the data that's coming in from your scanners, from your CMDB systems, any internal asset repositories, any internal business context sources, any threat intelligence sources. And once it's brought in, it's all there. It's all connected. All that we have to do is go through the relationships to get to the data that we want and make sure that it's built into our risk prioritization models. The second thing is that it defines an ontology. So it defines a common language in which you can process the data that's coming in. So again, think about it in terms of vulnerability management and even cybersecurity in general. One of the big problems that we all face as an industry is that there isn't a lot of standardization in terms of how we should do things, how we should have certain processes set up, how we should analyze information. So that's really the problem that this is addressing, where it's saying that, if we can build a knowledge graph for vulnerability management, if we can define an ontology that works for all of these data sets, that works for all of your vulnerability scanners, regardless of who the vendor is and who's providing that, if it can integrate with all of your sources of asset information and put them in a common language, then now we're actually talking about being able to compare data that's coming in from all of these different places that might originally look very different. But by defining a common ontology and mapping all of this incoming data onto this ontology, we're able to define a standard representation of risk and of our vulnerability management programs. The third key point is that it provides knowledge. So it provides original insights that are not available unless you put all of this information together and then you run certain processes on it. And the mechanisms to come up with this knowledge or this insight is actually built into the knowledge graph. So this is not necessarily, or this is not something that you're doing manually. This is something that the knowledge graph is expected to do automatically the moment that you start putting data in it. And then really importantly, it's alive, which means that as knowledge graphs grow, there is no way for us to know upfront what a knowledge graph is going to look like after some time. And the reason for that is because we haven't really started processing all the data yet. So as your cybersecurity programs and vulnerability risk management programs grow, as you bring in additional scanners, additional types of assets, additional context, additional threat intelligence, the knowledge graph is really in a very real sense able to evolve as that data comes in to be able to accommodate it. You have to expand the ontology, obviously, in certain cases if you're bringing in something that's completely different from what was already there. But it provides you the mechanisms to analyze all of this information together. Okay, so how does this relate to us? So the Brinqa Cyber Risk Services, which is really all the collection of services that we deliver to our end users and to our customers, they're really built on this cyber risk graph. And this is the knowledge graph for cybersecurity or for cyber risk. In our case, what this represents is it represents all the different assets that you need to monitor. It represents any incidents, vulnerabilities, gaps that might be identified from external sources. It represents any context that you can provide about these assets or about these vulnerabilities. So at the bottom of this image are some common data sources that we integrate with, and you'll notice that they are, fairly diverse. The owners of these systems tend to be different people. Sometimes it's IT, sometimes it's business, sometimes it's legal, sometimes it's compliance. But what we're really doing is that we're providing this common framework where you can bring in all of this information from different places and map it to a common ontology. And we're doing this through our cyber risk platform, which really gives us the technical capabilities to manage and manipulate this cyber risk graph. So data modeling, which has everything to do with representing the relationships between this data, the data connectors, which are responsible for bringing in this data and making the graph alive in a real sense. The decision engine, which is where all of the logic for insights and knowledge is built in. So things like, what should my risk prioritization algorithm look like? That's built into the decision engine, that's built into the knowledge graph. What should I prioritize to fix? How should I do it? Should I create tickets? Should I take certain actions in certain conditions? All of that is built into the decision engine. And then obviously the analytics engine, which is all about the presentation of information. So creating dashboards and metrics and visual representations of the risk graph and of the analysis that we're doing on it. So just really quickly, the ontology, I touched upon this briefly, so we'll just gloss over this, but this is a sample ontology for cyber risk that we start off with for a lot of our customers. But if you look at this, you can see that most of the components that you would expect to handle in this process are listed here. You have your assets with their relationships in the middle. Towards the left is the asset metadata or the asset context. Towards the right are all the different types of vulnerabilities, again, being mapped to common formats and common structures. Further to the left, further to the right are the threat intelligence feeds, which are actually enriching and enhancing the vulnerability data. And then below you have access-related things and remediation-related things, so tickets or more general tasks and actions. Okay, all right. So I know we went through a lot, but I promised that this was the end of the monologue. Now, hopefully, we can have a more constructive and more relaxed conversation about really what we wanted to talk about, which are the lessons from the field. And so at this point, I would like to invite James Walta. So Kayla mentioned that James is, and I should apologize, I forgot to switch the slides on the previous one, but the deck will be available through BrightTalk, so you can download that, and I would encourage you to go through that as well. But getting back to James, so James is our lead sales engineer, which means that he has a lot of visibility into how people are actually using our solution and what are the main problems that they're struggling with on a day-to-day basis. A lot of our customers, most of our customers actually, typically go through a POC process or a pilot process or some type of hands-on experience with the tool, which lasts between a week to maybe 3 or 4 weeks. And during that time, a lot of our customers actually validate most of their core use cases. And that's sort of what we focus on here, the main primary things that most people try to do or ask about when they get hold of our platform. So James, welcome to the discussion. Feel free to chime in at any point. And the first thing that I wanted to talk about was really something that is very significant to what we do, right? So our business is prioritizing risk, vulnerability risk or any other type of risk, but specifically focusing on vulnerability risk for our customers and making sure that the mechanisms and the algorithms that we put in place, working with them, that they are actually highlighting the problems that they should really be concerned about. The things that can have the biggest impact to their organization, the things that might be the most imminent in terms of highly likely to be exploited tomorrow that need attention right now, or things that just generally make it really easy for people to affect breaches and compromises, right? So would you say that that's kind of a big challenge that a lot of people face?
Yeah, and a lot of this particular challenge too comes from just, even if they do have the information, it's in multiple different locations, and that somewhat defeats the purpose, right? If you have to check 4 or 5 different locations to really get a good understanding of the information behind your assets, then it, for the most part, becomes irrelevant, and it requires a lot more manual effort than really what should be there.
Yeah, absolutely. And then also I think, it's what's really important to highlight here is that when we talk about risk, risk is really a subjective concept, right? The risks that I'm concerned about as a person living, let's say, in San Francisco are different from the risks that you probably encounter living in Austin, or somebody else in a different profession, a firefighter or a policeman. Their risks are very different from the risks that I'm concerned about. And it's kind of the same thing in this scenario as well, which is that before we prioritize what you must fix, it's really important for security organizations to have a good handle on who they are as an organization, not just the security side of things, but as a business. What are your main priorities? What are your main concerns? So for instance, quite a few of our customers are what would be qualified, what are categorized as critical infrastructure by the Department of Homeland Security. This covers things like your utilities providers, your airlines, your big transportation companies, your ONGC, oil and natural gas companies, because they interact with really critical things throughout the nation, like infrastructure that is very critical to the functioning of the company on a day-to-day basis. Things like power grids and things like airline control systems and oil fields. So for those organizations, it's really important that they prioritize the security around the assets that support and interact with these systems, right? So they want to make sure that anything that touches a power grid, let's say, that they have a lot of visibility onto those assets, and then when vulnerabilities are reported against those assets, they are prioritized accordingly. Another, I guess, flavor of companies would be things like Another flavor of companies would be things like your medical insurance providers or your credit processing companies, anybody that processes a lot of confidential and private data. Their main concern might be that they would want to make sure that all of their confidential data is protected. So any application or any asset that processes this type of data, that they're keeping their focus on those assets and making sure that all the critical problems on those assets are fixed. So really, I think, talking about what you can do to address these problems, definitely defining your risk priorities is right up there. You have to know whether you're more concerned about certain assets or certain systems or certain business processes, or in general your concern is more around preventing breaches across the organization, in which case you might want to look more on the likelihood aspect of things. How is your experience, James, sort of with bringing all of this information together? What do you see are some of the challenges, and how do organizations go about, addressing what is obviously a fairly complicated problem?
Yeah, and I think that's a great talking point. So a lot of the organizations that we work with have some understanding of, critical assets versus non-critical. Some of them do that through relationships to, organizational structures, so, critical business services, whereas others have a well-defined process for things like compliance criteria for assets. And so I'll actually switch over and we can take a look at how some of this can be accounted for within the Brinqa environment. But a lot of what we see is, customers having that information, but not a good way to use that in an automated fashion, or the ability to, quickly, at a glance, get that through a single pane of glass view. So here, what we're looking at on this screen is an example of a host page within Brinqa. So this is where we get all of our information relevant to a particular asset. Now, on this first column here on the left side, we see some of our more traditional, notification information. So we understand the operating system or the specific device type, and identification information as well, like the MAC address and the NetBIOS that comes across. But working with customers who do start to have understanding of either relationship information or down to the asset level, maybe the type of data that is stored on a particular asset, we can start to build out a more complex model that better illustrates the relationship of that risk. So here in the second column, we start to see various categories of compliance criteria. So this is actually a use case where, customers may have an understanding of a network segment that has HIPAA-related information or, PCI compliance criteria for a particular group of assets or known assets. And the ability to mark those within our environment allows for, the accountability when it comes to calculating that risk and elevating that for prioritization purposes above, a lot of the other assets within the environment that may not be so critical. The third column that we have is more to do with the relationships to that asset, not necessarily direct risk prioritization. So here we have up at the top a relationship to a business service. In this case, this host is helping serve the function for customer services. And then the network segment, it's also part of the critical assets network segment. So all of these are, various parts of criteria that can be used for that risk prioritization, and making sure that when we're calculating things like risk score for, the different levels of prioritization, that we can use all of this information to account for that. So if we take a look at, I've got another screen here, jumping up to that customer service level. So now we're looking at, a step higher than just the individual asset. And we can start to see, even on this level within the organization, where we still have additional prioritization information. So here we're looking at, again, a business service, so a group of assets, but we can attach things like business criticality to this overall group, and we can use that down at the host level to identify prioritization.
Yeah, awesome. And then also, I think, kind of in the same vein, network segmentation is also something that we are seeing fairly regularly now being brought into this process, right? Most of our new customers want to bring in network segmentation information, and it makes a lot of sense because network segmentation is really one of the first security measures that you put on your network. There is an inherent idea of how much risk is associated with a certain group of assets, or if you want to isolate really high risk or high value assets from those that might be getting a lot of traffic from, let's say, outside the network. And so we're seeing a lot of that as well, right? So we're not just looking at, for instance, in this case, your customer service is actually a business service, James, that you were looking at, but also IT data, right? Network segmentation is usually owned by some function of IT. So we're not just getting information from the business to evaluate these risks, but we're also looking at what available information does IT have that we can actually leverage towards this, right?
Yes, exactly. So if we go back and look at that host level, we talked about one of those relationships being that network segment, and it's not just about, you know, network segments that can be called out, but as you're saying, the direct relationship to some of that IT information. So even understanding whether an asset is in a DMZ or whether it's upstream or downstream of a critical database, or the firewall configuration that's in front of that asset, all of those are, you know, kind of pieces of the puzzle that really help identify not just criticality, but also contribute to the different risk factors that should be accounted for when looking at prioritization of risk.
Right. And I think one of the things that scares a lot of people when we kind of present this and talk about it is that a lot of organizations say that, oh, you know, that makes sense, but we don't necessarily have all of this information. Like we don't have a great CMDB, and we don't have all of this asset context. And our response to them usually is that, you know, one, you probably have it somewhere. You probably maybe just don't have it in your program, so we can actually go and look and find that and bring it in. But also that it's really important that, you know, whatever context you have, you bring that into the process. So even if it's not everything, it gives you some additional insight into how you can prioritize risk based on these considerations. And then also in the way that our model is built, you can always add additional context and additional data sources later on. So start with what you have, and then expand the scope of your programs. And so some final points on this, essentially this challenge. So kind of along the same lines of not having a great CMDB is also the problem of not having all the information about your assets. We actually had a customer that, you know, acquired us for vulnerability risk management, but really quickly realized that they did not have consistent asset information. So the first phase of their project was actually all about making sure that their asset information is accurate, and they used business rules to actually assign tasks to people to come and provide information about ownership or criticality or compliance requirements. And because this data model is available to pretty much everybody within the organization, they were actually able to delegate specific parts of that problem to different individuals and teams, and really build a great authoritative asset repository that they then use to prioritize their risks. Okay, anything else on this, James, that you'd like to touch on?
Just adding on to that too, you know, part of the process for this particular customer that you're talking about was also identifying where those gaps were. And so as you said, you know, using business rules to, you know, call those values out. A lot of, you know, the capability within the environment is around notifications and reports, and being able to set up those environments to specifically draw attention to those shortcomings in things like CMDB, so that way we can, you know, more quickly address the issues at hand and get the information that we may not necessarily know that we're lacking in certain conditions.
Yep. Awesome. So moving on to the next challenge. So far, you know, the first challenge was all about risk prioritization. How do we identify the main problems that we have to fix? But sort of the end goal of this whole process is that we actually want to help our bottom line as far as the security posture goes, right? So we actually want to improve our security posture. So we have to put a lot of emphasis on remediation as well. And when we talk about remediation, some of the primary concerns that people have, or some of the things that they want to achieve, is that one, they want to improve remediation effectiveness, which means that your remediation actions and tasks are targeting the main problems that you should be looking at. They're also improving your coverage. So increasingly, you're fixing more and more problems, and you have lesser number of vulnerabilities in your system. But the challenge with this becomes that, if you're just doing this ad hoc and creating a ticket for every single vulnerability in your system, it makes the problem worse. Because the people that are actually responsible for fixing these problems, they only have a limited bandwidth. Most organizations have fixed teams that are going to be doing this and being responsible for this. So we also have to be very, very cognizant of the fact that we're being effective in presenting. Oops, did we lose the? Oh, there we go. That we're being very cognizant about what information, what things we're giving them to fix, or what they're required to fix. So a lot of the emphasis on remediation is really put on defining good processes around remediation, and the way that we do that is through what we call our decision engine, or our rule-based ticketing engine, which kind of forces you upfront to define strategies for remediation. And it forces you to think about, who should be assigned certain kinds of tickets. It forces you to think about what the SLAs should be for certain kinds of tickets. And by formalizing these remediation strategies, what you're really doing is you're really helping with the consistency of your remediation efforts, because now you're not taking these decisions at runtime on a day-to-day basis. You're actually defining well thought out policies for how you should address remediation. So that's definitely a big aspect of what we do in terms of making sure that you're using your risk prioritizations to focus on your most important problems, and then also looking at things like patching information, which can tell you, for instance, if I have a patch that's going to fix 100,000 vulnerabilities and a similar patch that is going to fix 1,000 vulnerabilities, I can kind of prioritize what to fix based on those metrics as well. And then kind of trying to make sure that we're not spamming our security professionals. We also put a lot of emphasis on grouping things together, grouping vulnerabilities together, again, based on certain criteria like ownership or criticality or the type of technology or asset that is required to be fixed. What are some of the key thoughts for you, James, around remediation?
Yeah, so this one is a stickler a lot of times. I think it's overlooked the importance of a well-defined process when it comes to remediation. A lot of times, if it's not automated to like what you were saying, then it's also not consistent. And if we don't have a consistent process defined, then we're really just hurting ourselves at the end of the day and having a less efficient process. So if we take a look, I'll swap over here again. Let's see. It looks like maybe the webinar reset. Give me 1 second to share my screen again. All right. Let's see. Oh, perfect. We should be good to go. All right. So what I have here is an example of a ticket rule. Now, what's really cool about these ticket creation rules within the Brinqa environment is the ability to first start out by creating very specific and targeted ticket creation rules that account for very particular setups and requirements. But then on top of that, being able to have more generic vulnerability ticketing processes behind that to make sure that everything that is critical isn't slipping through the cracks. Now, part of this process, if we look at this ticket rule that I have here on the screen, in this case, we're looking at capturing vulnerabilities that are related to HIPAA compliant hosts. So this is a specific group of assets, and we're setting this as an order 1. So that way this occurs before any of our more generic ticket creation rules run. So maybe all of these are on a Windows operating system, but we will have a more generic Windows vulnerability behind this that will be in order 2. And where a lot of the automation occurs is looking at the various conditions that we can set for these rules. So if we look at some of the conditions, we have access to all of those different attributes that we were previously looking at. One of those was on the host level, and we saw on the previous host page where the asset that we were looking at was marked for HIPAA compliant.
And so what we can do is we can use that particular attribute as a condition and say only my assets where HIPAA is equal to true will this priority ticket creation run. And then below that, we start to get to some of the automation for things like assignment policies or SLAs. And what's really good about this is now we're starting to get into that defined ticket creation process and look at things like our HIPAA tickets should have a more escalated SLA or quicker due dates than just our generic Windows vulnerabilities, regardless of the risk rating or severity of that vulnerability. So this is where we can start to account for those differences in that process and do things like, create a 15-day SLA for all of our HIPAA tickets and automatically assign those tickets to the HIPAA service team. And then kind of the last thing that Syed mentioned there was efficiency within grouping of vulnerabilities to not overload our service teams. So consolidation is where we can look at all of those various attributes and group vulnerabilities based off of specific criteria. So in this case, for this particular HIPAA rule, what I've done is I've grouped or consolidated my tickets by the solution available for the vulnerability, and then split them up into the various service teams that they're responsible for. So the end result is going to be one ticket per service team per solution that's available, and it will list out, all of the available or all of the assets that are affected by that type of vulnerability. So we have a much more efficient workflow and much fewer tickets to handle from the remediation side.
Yeah, also, James, I want to kind of call out the fact that, all these actions that you're taking, whether it's consolidation or the criteria that you're setting for what should qualify for this particular rule or who should be assigned as an owner or as an actor, the fact that we have a graph behind the scenes, that makes it a lot more interesting, right? Because you're not just looking at a vulnerability's attributes or even the target that this vulnerability is on, the attributes of that. You can actually do infinite jumps to go from one end of the data model to the other end of the data model, looking all the way at the top, say looking at business services or network segmentation, and actually take these decisions based on that data. And the fact that we have a graph database behind the scenes and we can, like you're showing, traverse through essentially every relationship and every attribute of every relationship, it gives us a lot of control over how to manage the remediation process. And then just kind of switching back, James, I think we're a little low on time, so I want to run through this quickly. In the same vein as trying to reduce the overhead associated with remediation, another thing that you absolutely want to do and make sure is that you have a good process for identifying and resolving false positives. Because the last thing that you want to do is send a ticket to a developer or to somebody that manages a network and tell them to fix a problem and find out that problem does not exist. You don't want to have that conversation. So also put a lot of emphasis on cleaning the data that is coming in from your scanners, having a good process for managing false positives and so on. And then also, we cannot emphasize enough that the fact that you can automate a lot of these things, it doesn't just reduce your workload, it also significantly improves the performance of your program. So highly recommended that you do things like that you set up predefined policies and strategies for assignment, for SLAs, and so on. Okay, James, let's wrap this up. Anything else on this point?
No, I think that pretty much covers that particular challenge.
Awesome. So the third challenge that we kind of want to talk about and that we hear a lot is, how do I, as an organization or as a risk owner, how do I respond to things like 0 days, which you don't necessarily have a lot of insight on, and then you suddenly walk into work one day and it's the biggest thing in the news? How do you react to things like that? And then also fundamental problems like Spectre and Meltdown, where the impact of that problem is kind of unknown, but the exposure is immense. It's all over your infrastructure, and the remediations or the remediation options are unviable for long periods of duration. So how do you respond with tricky situations like these? And really, the most important thing is kind of building upon what we have been talking about is having visibility into what this means to your organization. So doing a really good job of being very quick in responding to providing information about how you're impacted, if your critical assets are impacted, if any of your critical business processes are impacted, having a good visibility into that and communicating that effectively can be significant. And then also one other thing before, James, I'll let you kind of walk us through some things, is also that you can have certain, you don't necessarily just have to rely on your scanning schedules to identify these things, because if that is the case, you could potentially be in a big, long gap where you don't have visibility into these systems. So employing strategies like passive scanning, where if you have a good handle on what's in your environment from an asset side, you can actually go and look at what your exposure is for these things as they're reported without actually having to run an expensive scan over your entire network. James?
Yep. No, so this is actually a great scenario to talk about. It happens, quite frequently. We're always hearing about new critical vulnerabilities in the news, and as things are coming out, or even more, retroactive vulnerabilities like Spectre or Meltdown that may have existed for a while, but once they were uncovered, it became a very large issue. And so, a lot of this is, as you said, it's just visibility into the metrics that we likely already have data on. So what I have here is actually an example of a report that we put together for quite a few of our customers when the Spectre Meltdown vulnerabilities first came out, and just the ability to very quickly identify things like new vulnerabilities based off of when they were first brought in. So like, here's all of our new Spectre vulnerabilities from the last scan. Here's our total number that are still active within the organization's environment. But then also being able to track our remediation efforts. So this third column is more focusing on our fixed number. So we can, compare our progress over time and make sure that, we're actually, remediating these actions correctly. And then same thing for Meltdown on the right three. And then what we have below that is a more distribution look. So we can look at the various operating systems within our organization that are affected by either the Spectre or Meltdown vulnerability, and really get a good feel for how it is impacting our organization based off of an operating system breakdown. So I think this is a really good example of a type of report where the data is likely already there, but without having good visibility on that data or a way to visualize that data, we have a very hard time understanding how our team is doing as far as resolving those particular issues.
Yeah, and even before we talk about resolving those issues, like in case of Spectre and Meltdown, which are very expensive things in terms of remediation actions, they can have a significant impact. Do you even need to take an action, right? Like, do you need to take an action because it might be the case that you're not impacted, or you're impacted in a way that is not really affecting you right now, and it's in a separate isolated network, or it's in a test environment, or whatever the case might be. Not to say that you should not take these seriously. You absolutely should, but the point is that without having visibility into what your exposure is and how you're impacted, it's not very smart to start taking actions without actually knowing that. And then on this, just a couple of other points, if you can just can do that. Just a couple of other points to kind of close this out. Make sure that you have predefined processes for how you want to handle these kinds of problems. Especially for 0 days, make sure that you have dedicated remediation strategies that are set up that outline what the SLAs should be, who should fix this. Have these conversations with the folks that are going to be responsible up front so they know what to expect. And then also we're seeing increasingly customers not just create tickets, but also plug in orchestration pieces to actual systems that can take actions on behalf of this, right? So things like your patch management systems, make sure that your patch management is very streamlined, and if you can actually take automated actions, if you can completely rely on the logic of those actions, you can actually trigger, for instance, decisions based on this information that is coming in from Brinqa to external systems where you're actually fixing these problems as well. And then obviously, actively track remediation progress through these kinds of reports to make sure that you're seeing that your risk is decreasing as time goes on. Okay, so I think we're running a little short on time, so we'll run through the last few segments. The next challenge really, James, that we see it with a lot of people and that they don't necessarily realize is something that is important to them is the fact that you have to future-proof your vulnerability risk program. And we've seen this come up in lots of different ways. So for instance, one of our customers was using a network scanner a particular network scanner when they started using Brinqa, and then about a year down the line, they actually changed their network scanner, which is a huge enterprise, right? It's a big undertaking for an organization, especially one that is large. So in that case, you want to make sure that you're adjusting and your program is able to handle those kinds of scenarios. Similarly, you could have new types of assets. So you could have IoT devices, which almost nobody is considering as part of their vulnerability management programs right now, but that is something that we have to start looking at very seriously in terms of how are we going to evaluate the risks and vulnerabilities associated with all of our IoT devices. So we have some customers that are starting to bring in that information, and it's a really interesting space. So what are some of the interesting things, James, that you're seeing on this?
Yeah, I mean, as you said, this really is, it's kind of a common problem, right? There's always going to be new technologies that are coming out, or as organizations expand upon their vulnerability management program, they're going to start using more tools, gather more information about their assets, and there's always going to be the need to provide something new to existing objects. And you mentioned it a couple times, but I think this is really one of the most powerful things about using those graph relationships to all the objects. As we bring in new data sources, we're able to flexibly define those objects over time. So for example, if we have a directory that starts to establish the different environments that our assets are in, right? If we start to better understand what's in production versus test versus development, then we can add those definitions to the existing asset data model and start to account for those and be able to dynamically map those over time. So it really can have somewhat of a retroactive effect, and we can work with all of the existing host models, add that new attribute, and then bring in that new data source pretty dynamically, just directly within the UI there.
Yeah, awesome. And then, really having the capability to sort of expand that ontology by creating more data models or by expanding the relationships and attributes, you can really kind of adjust for any changes in either in the external environment or within your own infrastructure. And that's definitely something that we see a lot of customers maybe not necessarily realize up front, but once they get to that point, they're really able to appreciate the fact that they can do that without any impact to their existing processes. And then finally, we wanted to talk about something that we're seeing increasingly from a lot of our customers' requests for, and which is the challenge that, how do you implement continuous vulnerability risk monitoring? Because most organizations have very specific scanning schedules. Sometimes organizations might be scanning certain parts of their infrastructure, especially on the network side, maybe a few times a year. So how do you adjust for problems that might be occurring between those scan periods? So if a 0-day or if any vulnerability is discovered today or announced today, do I really have to wait for 3 months to see if I'm impacted or not? And we're seeing a lot of interesting approaches to this problem, the most prominent one being passive scanning, which also kind of ties in, again, back to the asset management piece. But if you have a good handle on your asset management side of things, and you can actually map your assets to standard CPEs without any scanning or without really doing any type of intrusive scanning or testing actions, you can actually get a pretty good sense of what your exposure might be to a particular vulnerability. Because you have, any time that vulnerabilities are discovered, NVD actually goes and updates those vulnerabilities in their database, make sure that the actual product that is impacted or products that are impacted, they're listed. So if we can establish the mappings between our product assets, our asset repositories and the instances there to these CPEs, we can actually come up with a list of probable vulnerabilities, right? I mean, those might not necessarily be the problems that exist. You might have fixed some of them, but it gives you a pretty good idea about what problems could be out there. Now, some challenges with this is that, you know, the change in configuration management systems, they're not very standard in how they name and present assets or different product types or softwares. So the big technical challenge here is, how do you map these values, which could be anything, to these actual standardized CPEs? And that's really what a lot of emphasis for us is on, using probabilistic matching, where we're not just looking at the actual values, but we're looking at additional characteristics to make some inferences about what this product could be, and then continuously using our graph database with some type of supervised learning to basically better those decisions. And so this is an interesting space for everybody to keep an eye on going forward. I think you're going to see some great developments in this space. Okay, so we are at the end of time. I think we have a few questions, but Kayla, maybe we can just answer them offline. So for me, thank you so much to everybody for joining this webinar. We hope it was informative and it was useful. You can close it out, Kayla.